Okay, so this is Math 2300, which is Introduction to Rule Analysis. Okay, and then we want to revise some of the questions in sheet 1 for 2024. Okay, and then it starts with proofs. So we have to prove that a certain composite set is equals to another composite set. Okay, so basically that's what question 1 is about. And we know that if we want to prove that set A is actually equals to set B, then it's a two-way proof, okay? Meaning we have to show that set A is actually a subset of B, and then the B is actually a subset of what? A, okay? So if we can show this property, and then we can also show that property, then it means the two sets are actually equal, okay? So that's what we are going to try to do here. Okay, so we go to the first one there, which is a very common proof and very easy to follow. So this is question 1A. Okay, so they are saying proof that X union Y intersection Z, it's actually equals to we have X union Y, and then intersection X union Z. Okay, so this is what we have here. So the first part of the proof is always to assume, or you suppose, okay? So we are going to say suppose, okay, I'm not going to write all the words here, but I'll be explaining it and hoping that you follow it. So we're going to say suppose, okay? Suppose that we have an element X that is a member of this set that we have on the left-hand side, okay? Suppose that X is a member of this set, okay? Then by definition, okay, we know that this X here will be a member of this set X, and it will also be a member of Y intersection Z, okay? So you can say by definition, so by definition, okay, we know that X will be a member of this set X, and then this union in words, we say it is O. X is a member of Y, and then this intersection, it's and in weight, X is actually a member of the set Z, okay? So this is the condition that we have by definition, right? By definition, we have that. Okay, and then from here, we can see that we can actually group the first X in this set X, okay? We can unionize it with the Y, and we can also unionize it with the what? The Z. So we are going to say, you can write it follows, okay? So you can write it follows that this X, okay, is actually a member of X, or it's, okay, let me write it properly there. That X is actually a member of set Y, and then you say and, okay? So you are grouping this guy here to the Y and the Z. So here you're going again to start with X is actually a member of set X, okay? Or my X is a member of set Z, okay? So you can see what we formed here, because we said the union represents the word or, and then the and represents the what? The intersection, right? Okay. Okay, so here what we have, since X is a member of this set X, and this X is a member of this set Y, okay, then it just means that the X is actually a member of X, okay, and then this O here becomes the union, okay, and then the Y, and then the and in between there becomes the intersection, okay, and then X is also a member of this X, and X is also a member of that set. So you're going to see okay, maybe before we complete it here, because you have to show the steps. So here I'll just say and again, and then I'm going to say X is actually a member of, okay, then I combine what I have here, which that's X union what? Z. Okay, so this is what I have, and I know this is an intersection. We have X, which is in here, and this same X is also in there. Okay, so we can actually intersect these two. Okay, so from this, we see that X is actually a member of X union Y intersection X union Z. Okay, so this is what we have. And when we reach here, we realize that what we have here now is what we had on the right-hand side, right? If I could go back here, when we started the proof, what we had there is this now, okay? So we started with this, and then we have ended up with that, okay? So this shows that the first set there, which was X union Y intersection Z, is actually a subset of this guy here, right? Okay, so it's actually a subset of this guy. So if you have any question, don't hesitate, just unmute yourself and ask. Intersection X, then you have union Z there. Okay, so you can name this as your equation 1. So you can say, this is my equation 1. Okay, and then now you prove the other part. Now we show that this guy here is actually a subset of this. Okay, so you're going to say conversely. Okay, you're going to say, what's happening? You're going to say conversely. Suppose that, okay, so conversely. Okay, Kaya, what way I'm writing? Is this the spelling for converse? Okay, so you're going to say conversely. Suppose, okay, suppose that the X was a member of the set on the right, then we have to show that it is a subset of the set that was on the left. So suppose that this X is actually a member of X union Y intersection. We have X union Z there. Okay. So suppose that X is a member of that. Okay. Then we know that by definition, what will that mean? Okay. What will that mean? It will mean that, okay, so you can say by definition, it means that the X is actually a member of this. So you can say X union Y, and then that intersection becomes the and X is a member of X union Z. Okay, so this is what we have. So if X is a member of this, then by definition, okay, then by definition, X is a member of this X union Y, and it's also a member of X union Z, okay? And then from this, we can expand. So we can say it follows that this X will be a member of this set X, right? So this X will be a member of set X, or X will be a member of what? Y, okay? So this union has turned to an O. Okay, and then we say, and even here we do the same. We have our X, which will be a member of the set X, or the X will be a member of what? Okay, will be a member of the set Z. So that is what we get there. And then we see that X is a member of set X, X is a member of set X is common. Okay, so that means that we can actually like factorize the X is a member of X. Okay, so what we get from there is X is a member of X, and then I have this O here. Okay, so I'll write O. X is a member of Y, and X is actually a member of what? Z. So this is what we have, and we know that we can write this in symbolic form. So meaning this would be X is a member of the set X, and then O, and then here we see that we have an AND here. So we can write this in terms of intersection. So it will be X is actually a member of what? Y intersection Z. Okay, so this is what we have. And then X is a member of this set X, or X is a member of this. So meaning we can put the union there, okay? So it actually means that X will just be a member of this set X union Y intersection Z. Okay, so this is what we have. So you can now see that we started from the right-hand side, we have ended up with what we have on the left, okay? So this actually means that what we started with is a subset of this. So we had this at the beginning. Well, this should be X union Z. Okay, so this guy here, since we started with this and we have ended up with this, it means it's a subset of what we have there, which is the X union Y intersection Z. Okay, so you can see this is my equation 2. Okay, so now since we've shown in both directions that those sets are subsets of each other, okay, so it means they are equal. Okay, so you can say hence if I combine, okay, combine my equation 1 and my equation 2, okay, I have that X union Y intersection Z will actually be equal to union Y, and then intersection X union Z. Okay, so this is what we have, and you say hence the fruit. Okay, so that's how you prove the first question there. So I don't know if you have any questions on the first question.
I have no question.
Okay, I can proceed.
On the first question. I think you can do question 1, question 1E.
Okay, question 1E. Okay, so let's do that.
Yes.
Because here you use the same principle, even here, even here. So let's do question.
Yes.
So
Yes. No, I thought someone was asking a question. Yeah. So let's do E. Okay, so E is.
I had a question.
Oh, you have a question? You can ask.
And all parts where you explain.
You can ask your question. What's your question?
The question was on the part of the and the and the or.
Uh-huh.
What were they? Yeah, what were they denoting with set operations?
What we are really denoting is what?
You said something like that the or means intersection and I don't know if I've confused them, so I wanted you to repeat on that part.
Oh, okay, okay. I was saying the union there is related to the word or, and then the intersection is the word and. Okay, so there in the question where we had or, we are replacing it with the union, and then where we had and, we are replacing with the intersection, or vice versa. You've gotten it?
Yes, understood.
All right. Okay, so let's do question E. Okay, so on E, we had X minus Y. It's actually equals to, I've forgotten, let me check. Okay, X minus Y is equal to X intersection Y complement. Okay, so we want to prove this this function here. Okay, we want to prove this function here. Okay, so we can see a set difference there. So you have to have the knowledge of what the set difference means, right? Okay, so it's a very simple proof. We just have to show that this guy here is actually a subset of this, and then this guy is a subset of this. Okay, so we always start with suppose. Okay, so suppose that we have an X. Okay, so suppose that we have an X, which is actually a member of X minus Y. Okay, then what does this mean? Okay, so you have to know the definition of a set difference. Okay, so if X is a member of X minus Y, then it actually means by definition of a set difference, okay, that X is a member of this X, okay, but that X is not a member of this Y. That's what it means, right? Okay, so you can say by definition there, we have that, okay, X will be a member of the set X, okay, and then you say and X will not be a member of the set Y. Okay, this is what it means by the set definition. If you have something like this, where another set subtracting another set. Okay. Okay, and then from here, okay, from here we can see that we can maintain this guy here. Okay, so we can say this X is still a member of X. Okay, then you write your and. But here, okay, here we use now the complement rule. So if X is not a member of Y, then it actually means that what? It actually means that X is a member of Y complement. Okay, do we agree with that? Do we agree? If X is not a member of Y, then it means that X is a member of Y. Okay, yeah, so you use that's the definition of a set difference, and then you use the definition of the complement, okay? So if X is in X and X is in Y complement, then it means what? It means that X is actually a member of X intersection Y complement, okay? So you can see now that we have what we had on the right side here. We have this, we started with this, and then we have that, okay? So you can therefore say that X minus Y is actually a subset of X intersection Y complement. And then you can put this as your equation 1 like that, okay? So we've done half of the proof, and then now we do the converse, right? Okay, so you can say now conversely, what do we have here? Okay, conversely, suppose that, very important to assume, okay? Suppose that we have an X here. Suppose that X is a member of X intersection Y complement, okay? And then from this, by definition, okay, by definition, we see that, okay, so I can write by definition. So we are just going in the opposite direction of what we are doing on top there. So by definition, it means that X is not a member, or I mean, is a member of X, and X is a member of Y complement, okay? And then okay, just from here, I think you can even get the definition. Okay? So if X is a member of X, and that X is not a member of Y complement, is a member of Y complement, I mean, okay, then it means what? It means that X will still be a member of this X, but, or not but, I say and X is not a member of Y, okay? Because here X is a member of Y complement. So meaning the X is not a member of Y complement. And we see that what we have here is just the definition of the set, the set difference, right? Okay. So from there we can see that actually X is a member of, okay, because what we have here is the definition of the set difference. So X will be a member of X minus Y. Okay, so we started with the right-hand side, we've ended up with the left-hand side. Okay, and then from there, we can actually tell that X minus Y is, no, we're supposed to write the opposite. Okay, so we're supposed to write X intersection Y complement is actually a subset of X minus Y. And then we can name this as our equation 2. Okay, so this will be our equation 2. Now, since we've proved both directions, that the right-hand side is a subset of the left, and the left is a subset of the right, okay? So you can even conclude now, you can say, therefore, if I combine my first equation, okay? So therefore, combining my first equation and my second equation there, okay? I get that Y minus Y is actually equals X minus Y, I mean, is actually equals to X intersection Y complement. Okay, then you can even say hence proved like that. Okay, so any questions there?
From me, no question.
Okay. Okay.
I think we can.
Okay. Okay. Yeah, so basically what you do here on question 1 is it's just the same principle. You have to know the basics of the set operations, right? You have to know when they say union, what do they mean? When they say complement, you have to know the complement rule. You have to know the set difference, okay? And then you also have to know the Cartesian product, okay? You also have to know the Cartesian product. Then you can prove all of them there, okay? So I think I can go to number 2. We try to solve some questions from there.
Excuse me, sir. I've got a question on the Cartesian product.
Yes, you can ask.
For me, I find it very difficult to prove the second part. Maybe you can know how we can go about it.
So we can do E. I mean F.
Yes,
Okay.
just the last part.
Okay, the last part
Or
showing
maybe for
that.
the sake of everyone, you can do it.
Okay.
I don't know.
Okay, let's try to do F. Okay, F. What do we have there? Okay, so we have X, okay, Y, and then, okay, we're just exchanging the brackets. So if we have X, and then Cartesian product, X, Cartesian product Z is equals to, and then here we begin with X and Y, and then the Z is outside there, okay? So we'll have to show that this is actually a subset of this, and then this is actually a subset of that, okay? So we use the Cartesian products that involve 3 sets, because I can see X, Y, and Z there, yeah? So you can say, since here, this one here is together, okay, we have the Y and the Z together, and then the X is alone, okay? So this is a capital letter. Okay, maybe I can even use A and B and C to avoid confusion. So you can say, suppose we are proving that this is a subset of this. Okay, so suppose that I have a set, because this is a Cartesian product, so it has to be in form of a coordinate, right? It's not a single element. So suppose that I have this set where I have A, comma, okay? So this A is in this set X, and then I have a pair of coordinate B, comma, C that are actually in this Cartesian product of this set, right? Okay, so suppose that this coordinate here is a member of the first set that we have there, Y, and then we have Z there, okay? Okay, suppose that we have that, where we know that this A is in the set X, and then B is in the set Y, and then this C is in the set Z, okay? But when we combine the coordinate B, comma, C, it's in the coordinate, it's in the set of Y multiplied by Z, okay? Okay, so by definition then, so we can write by definition, okay? So by definition, what do we get from there? Okay? We get that, oh, I've written X, I'm used to X. So we get that the A is actually a member of set X, okay? And then the other coordinate here is the code is it's a member of this set here, okay? So we can say, and the coordinate B, comma, C is actually a member of this set here, the Y multiplied by Z. Okay, so this is what we have by definition, right? Okay, then from this, it can follow that. Okay, so you can write it follows. It follows that. Okay, the A is still a member of this X, and then I have and, okay, and then here, since we also have a Cartesian product here, we can actually separate the set and say that my B is a member of the Y, okay, and my C is a member of the Z, okay? So C is a member of the Z. So that's what we have there, or what follows, okay? Okay, so here we started with what? What did we start with? Okay, so when you reach here, you can actually, because we're just playing around with the bracket, so you can actually now group this A and group it with the B, and then you leave out the C outside there, okay? So from this, we can have, so you can write, we can have that, okay? And then let's group the A with the B, and then we leave out the C outside there, right? Okay, so from there, we have that the A, comma, B will actually be a member of the Cartesian product of X and Y, like that, okay? And then the C there will remain outside there. So you can say that I have the Z, not the Z, I mean the C, which is a member of the set Z. So, and the C, which is a member of the set Z, okay? So you've seen we have just switched the brackets, right? We just switched the brackets. And then what we have here is actually what we have on the other side, okay? So if I can complete it here, I will actually say that my coordinate A, comma, B, okay? And then I take it as one coordinate, comma, this coordinate, which is C, okay, is actually equals to, not equals, I mean, it's actually members of the set X multiplied by Y, okay? And then, okay, so X multiplied by Y, then I multiply by Z outside there, okay? So you can see that we started with the Y and the Z in the brackets, okay? And then we have ended up with the X and the Y. So we have switched the brackets actually. That's what we are doing here, okay? So this shows that what? This shows that what we had at first there, which was Y, then Cartesian product with the Z, it's actually a subset of what we have here. So we can write X, then say Y, and then Cartesian product the Z, okay? So this here becomes your first part of the proof. So we have done the first part, and then now we can do the converse, okay? So the converse, it's actually similar, okay? It's actually similar. So you see how we shall do it, okay? So we can say conversely, suppose that okay, suppose that I have an X, no, not an X, but a coordinate, because this is Cartesian product. So you have to use a coordinate, okay? So conversely, suppose that I have A, comma B, which I'm taking as one coordinate, comma C, okay, which I remember of the set that I had on my right-hand side. So on my right-hand side, I had X, then with the Y there, and then Z there, okay? So we can still say by definition, what does that mean, okay? So we know that the A comma B is a member of X comma Y, and then the C is a member of the Z, okay? So by definition, we know that A will be in X, B will be in Y, C will be in what? Z, okay? So by definition, we know that A will actually be a member of X, and then we have B, which will be a member of Y, okay? And then we have the C. Okay, let me just write it here. So C is a member of Z. Okay, so that's the interpretation from what we have.
Sorry, sir. Just a question.
Yes.
Yeah, just this first part is what confuses me. So I when solving, I get confused. Like, do we just have to like separate them directly just from here, like the A comma B, or you could just say A comma B is a member of X, the Cartesian product of Y.
Okay, so you can,
or it's just fine, like just
okay,
go direct like this.
You can actually go both ways, okay? Because if you say A comma B is a member of X comma Y, still if you separate those 2 points, you still end up with this. You still end up with this.
Oh,
you see it, right?
okay, yeah.
So if you say A comma B is a member of X cross Y there, okay? If you separate it further, you still end up with A is a member of X, and then the B will be a member of Y. You still end up with.
Oh, yeah. Yes.
Yes. So from here now, okay. So we see that by definition, we can now write what you are saying. You can say A. Here we're just showing where they are coming from here, okay? And then we can now take it as it is. So A comma B will actually be a member of this, okay? And then you say and, because this is the Cartesian product, and then you say C is actually a member of what? Z, like that. Okay, and then actually, anyway, it's fine. So this we said it means this, then and Y is a member of Y, and then you say and C, it's a member of Z there. Okay, and then now you can switch the bracket. You can take the other grouping. Okay, you can take the other grouping. So this, what does it actually mean? Okay, what does it actually mean? It means you can group B and C and leave out the A. So you say A is a member of this X, okay? And then now these two here, you can form a Cartesian product, okay? So you say B comma C will actually be a member of the Y cross Z there, okay? And then from here, we get what we want from here. We can even see, right? Okay. So therefore, if I combine all this, I get A as my first coordinate, then my second coordinate will be B comma C, and then all of this will just be a member of what? Okay, I start with my X where the A is, so X, and then cross, and then where the B and C are, which is Y cross Z. Okay, so we see that this is actually what we have on the left-hand side, right? Okay, so you can again conclude that my X cross Y cross Z, okay, is actually a subset of what we have here, which is X cross Y cross Z, like that. Okay, so we have this, and this can be our equation 2. And then, since we've shown that they are both subsets of each other, we can say combine. Okay, so if we combine 1 and the 2, okay, if we combine the 1 and the 2, we actually get that this is actually equal to the expression that we have on the right. Okay, we actually get that this will be equal to X cross Y and then cross Z. Okay, you can say your hands proved here. Okay, so that's how you do that. And then we can actually go to question 2.
Thank you, sir.
Okay, so let's try to solve question 2 now. So question 2, we are representing different kinds of sets on either a number line, or you can represent it in plane, or we can actually represent it in space, okay? Okay, so let's do that. So the first one, they are saying the set X1, okay, we have a coordinate A comma B such that the coordinate of A, okay, should come from the open interval of from -1 to 1, but B can be any real number, okay, can be any real number. So you have to visualize this, and then we can actually draw it, okay? So I have the set X1, where they're saying what? They're saying A comma B is such that, okay, the A should be a member of the open interval from -1 to 1, and then the B is a member of what? Of the real numbers, like that, okay? So it means the choice of A is actually restricted. You can only get values, okay, that are less than -1, okay, and values that are less than 1, okay? So it will be restricted in a vertical strip, if I could say. So if I actually draw my X y-axis here, okay? So if this is my X or Y plane, and I say this is my X, and then this is my Y, okay? So the A there represents the X, and then the Y represents the what? The B, right? Okay, so this A can only be from -1, we can put -1 there, 0, then here we can put 1. So you can choose any value here of A, okay? You can map it to any value of A here can be mapped to any value of Y, okay, in the Y-axis, like that. Okay. So meaning, what do we have here? We have values that are between these two lines here. So you draw one vertical line at -1, and then you draw another vertical line there at 1, like that, okay? So the choice of A will just be between this, but the choice of B can be any value, okay, going up here to infinity, even going down to infinity, like that, okay? So you can actually just shade that part in between to represent this set Okay, so you can say this part here, all of this part here, I can get any value of y, okay, as long as my value of x is in between those two lines here. Okay, so here make sure, yeah, where is the screen going now? Okay, so make sure here that you have that you dot these lines here. It should be dotted. Okay, these lines should be dotted because we are not including the 1 and the -1. So you need to dot these lines here. Okay, but if we had a coordinate such as a comma that with those square brackets here, then this line here will be a solid line because we're including the a. Okay, even there will be a solid line because we're including the a. Okay, so you're supposed to write this coordinate, not the a comma b there. Supposed to write -1 here and 1. If I had this here as my interval for this a, okay, then it would mean this would be a solid line, even that would be a solid line. But here it's not a solid line. So make sure you dot it and then you just shade in between here, okay? If you want, you can shade it. Okay, so that's how you present that set. Any questions? Okay, and then let's do the second one. Okay, and then this is set x2. They're saying rational numbers, we are just subtracting counting numbers, right? Okay, and we know that counting numbers, which are natural numbers, are just numbers that start from 1, 2, 3, 4. Those numbers you can use to count. And then rational numbers, we know that all the numbers, right, that can be expressed in the form of a over b. Those are rational numbers. So what actually you can do here is come up with an arbitrary number line, okay, if we represent this on the number line, okay, not actually the normal number line, but we can say that we have a number line here that represents these rational numbers like that with these symbols. Okay, and then we can plot some numbers. So if I have 0 here, I have 1, I have 2, I have 3, and then I have 4 there. And then on the other side, I can have -1, -2, -3, and then I have -4 there. Okay, so what would this mean? Yeah, what would this mean? It would mean that from the set of rational numbers, I'm just removing the natural numbers, okay? And I know that the natural numbers start at 1. So I can actually, since this whole line here, this whole line that I've written here in red represents the rational numbers. So to remove the counting numbers, I can just be drawing an open circle there, an open circle there, even there an open circle, even there an open circle, just continuing where it's going here. If I had the 5 there, I'd put an open circle too. So this shows the set where you have rational numbers minus the natural numbers like that. Okay, any questions there? So you just have to exclude the natural numbers. Okay, I can continue.
In the plane or in space. So you use what?
Recording in progress.
In the
Okay.
Oh, it
question.
was stated.
Yeah.
Alright, thanks.
What are you saying? Hello? Hello?
So I was asking,
Yes.
ending anyway is fine.
Yes.
Oh, all right.
Okay. Okay. Hey,
I
why
also
am
wanted to ask that is there a possible way of drawing it so that you show that it's infinite, like even to the numbers that you find ahead of 4, they won't be. Is there a possible way of writing that?
okay. I don't know anywhere that I can write showing all those numbers. Maybe I can just write the infinity symbol there and show a dotted line and then an open circle on top there. But I don't know. But even this representation here, it still shows that you are excluding the natural numbers. Is that okay? Or do you know a way that we can represent it? Hello?
No, this is the only way I've come across as well.
Okay, yeah, it's what I know.
Yeah, it's what I know.
There you go. Do you have
All right, I
another way?
thought you were going to put some dots. I thought you were going to put dots, like 3 dots to indicate that it's continuing.
Here, like put 3 dots, like what? How? Like this?
Yes, like you remove the arrow first, there where you have put the rational numbers, then you just put the dots in the arrow.
Okay, I think even that one can
Yes,
work.
that's what I thought.
Okay, I think even this, you can't be penalized. And then you say it still continues going like that. And then this is the set of rational numbers like that. I think even this representation is okay there. Okay, and then let's look at the other one there. Okay, so the other one there we have this one, the set x3, where we have a mapping of integers with integers. Okay, so we know that integers are just what? Non-fraction numbers, right? But they can be negative, they can be positive, we can also include a 0, right? Okay, so we have this mapping here. So Z3, and then we have set of integers being mapped to a set of integers like that. So meaning that if I draw my XY plane here, okay, so here it continues to go, even in the X direction, it will continue to go like that, okay? So from this first set of integers, I can get any X value, or I can get any Y value, even from this set here. I can also get any X value, right? Okay. So for just an illustration, I can say this is 0, 1, 2, 4, 5, and then this arrow indicates that it continues in that direction. Then also here, you can have this. Even on the Y, you can have -1, -2. Okay, and then 1, 2, 3, just like that, okay? So this mapping here means that every integer, okay, is actually mapped to itself, and it's also mapped to the other integers, okay? So if I can have a 0, 0 there, let me use red. Okay, so if I can have a 0, 0, then I can draw a dot at 0, 0. 0, 1, can do a dot. 0, 2, 0, 3. Even this one here, it can follow suit. I can also have a 0, -1 there. So every point there is actually plotted. Okay, so you end up with something like a grid. Okay, so all these points will be plotted here, but it's continuous. It doesn't end with just this illustration there. Okay, so you can write it like that. You can show it like that. So all the points, they are actually mapped to themselves, and they are mapped to other integers. So I was forgetting this one here. Even this one, it will be the same. Okay, even from this side, you still have the same mapping like that. So you form a grid like. So we have that. Even here, there they are there. Yeah, even here. So you just continue illustrating it until you reach where you are satisfied, I think. Okay, so if you see it here, it will look something like a grid, right? Look something grid like pattern where we have points, okay, that are mappings of each other, and those points, they're just integers, okay? They're just integers. An integer that is mapped to another integer, just like that. Okay, I think this is simple, right? Is it hard?
It's simple when you understand it.
It's simple when you understand it. Do you understand it? Do you understand it?
After you teaching, yes.
Okay, that's okay. Okay, that's okay. Okay, let's try to plot 4. Okay, let's try to plot 4. What do you have on 4? What do you have on 4? Okay. The background there. Turn off background there. Okay, thank you. So here we are x4. So we want to plot this, and we realize here that this a squared plus b squared is less than or equal to 2. It's actually just in the form of the circle, right? That is just the form of the circle. So we have these coordinates a, comma b, okay, that are actually points that are greater than that are found outside the circle, okay? Because here they're saying greater than or equal to. So within that boundary of the circle and all the points that are outside, this is the mapping that we have here, a, comma b. Okay, so let me illustrate here before we do the actual one. So if I have a circle like that, okay, and then I shade outside like that, it means I'm getting points, okay, where the a, comma b, those values are outside here, or they are on this same line here. So this will be this one, greater than or equal to. And then if I have a less than or equal to, it means I'm getting points that are on this line, and then they are inside here. Okay, they will be inside here because that is less than the a squared plus b squared. And then I can also have this situation where I have a dotted line here, okay, and then I shade outside here. So this situation will be what? Will be just greater than like that. And then I can also have a shaded here, and then I have a less than here. So meaning the point that will be shaded will be inside the circle, but not on the boundary, okay? So we can see that in our case here, we recognize that this is just the equation of the circle, right? Okay, and we have a greater than or equal to. So meaning we just want to shade outside this circle, inclusive of the points that are in the boundary of the circle. Okay, so what do? We first have to find the radius. Okay, we have to find the radius, and then it will help us to draw the circle on the x or y plane. Okay, so how do you find the radius? So if I have x squared plus b squared, okay, so if you're taking Mat2300, you know the equation of the circle, right? Okay, so here you're being given is greater than or equal to 2. So we know that the radius there is actually just the square root of this value. Okay, that is on the right, because the equation of the circle, we said it was x squared plus b squared, and then we have an equal to, and then r there. Okay, so we know that this should be r squared, right? Okay, so this r here, we find it by just square rooting what we have there. So we can actually find the radius of this by saying the square root of the 2 that is there. Okay, so this square root of 2 will be our radius. And we see that this circle here is not shifted anywhere, because this a, does not have a minus something or a plus something. So meaning its center is actually at the origin, okay? And then it has a radius of 2. So if I would draw it here, this is my x or y plane like that, okay? I would have the origin here, and then I want to draw a circle that will have this radius here, which is just the square root of 2. So the square root of 2 is about, I think, 1 point something, okay? Square root of 2 is 1 point something. So you can, if you are drawing it in the book or you're drawing it in the test or something, you can just actually measure something like 1 point something here, okay? 1 point something there, even there 1 point something, 1 point something, because the radius should be the same everywhere, right? Even here 1 point something, and then around that 1 point something, you draw a circle here. My circle is bad, but you should draw a good circle. So you draw a circle there, okay? Then you indicate that actually this is just my radius, and that my radius is actually the root of what? 2. So that's what we have. And then we want to represent that set. Wait, I didn't write the set. Okay, it's this set. So I can say A comma B such that, so I have this set. So I want to represent all these points here that are greater than or equal to the radius of this circle, which is just what? The root of 2. So I'm going to shade outside here. All these points that are outside here will be included as the points that represent that A comma B there. Okay, so all these points, inclusive of the points that are within this boundary here, because that was greater than or equal to. So we are including these points here, and then we are getting all the other points that are outside here. So that's how we represent that. I don't know if we have any question there. Okay. Yeah, so you can represent it like that. So it's just an area outside the circle with the radius 2. Okay, that's that on that one. Then we can do the last one, I think, which is this guy here, which is very complicated if you don't know spaces. If you don't know spaces, it will seem very, very complicated. Okay, so in space, if we're representing something in space, just simply means that what? Okay, just simply means that we are using a 3-dimensional coordinate system. Okay, so the one that we are used to is actually this one here, which is a 2-dimensional coordinate system. Okay, but to this coordinate system, we can add another axis like that, and then it becomes a 3-dimensional coordinate system, right? Okay, so you can actually represent your axis. You can put this as your Z, okay? You can put that as your Z. You can put this as your Y. What's happening to my pens? You can put this as your Y, then you can put this as your X, okay? So we want to represent these coordinates here, okay? They form a bounded area. So we want to represent that bounded area on this 3-coordinate system here, okay? So yeah, do you have any idea what we should do? What's to represent those coordinates on there? Do you have any idea? What do you think we should do? Hello?
What's the question again?
The question is, how are we going to represent this set here, which is in 3 dimensions? How are we going to represent it in space? Okay, so in space, we just simply mean 3-dimensional coordinate system. So how are we going to represent these points here? That was my question.
I have no idea.
Why don't you have an idea? Okay.
Okay.
Okay. Wise man, what's your idea there? How are we going to represent them?
So with me, I'm thinking, since we've got the same coordinate, the 0, where they're meeting, well, all the 3 planes are meeting, we say that's 0. Then from there we make like a box using the same coordinates. I don't know.
Okay, so actually, you can take this first interval here as your x coordinates, and then you can take the second interval as your y, and then you can take the third interval as your x coordinate, as the interval in the z. Okay, so we can say this is our x for simplicity. This is our interval in the y. Then this is our interval in the what? In the z. And then this can actually help us to plot it. Okay, so let's try to plot it now. Where is vertical board? Okay. So I have x5, which is equal to 0, 1. We said this first interval represents the interval in the x, right? And then we are multiplying it, or we are crossing it with the interval 0, 1. Okay, and then we said this would be y, x, and then we have our z now. So our z is 0, 1. Okay, so it's very much important to pay attention to the brackets that they have put here. So it means in the x, okay, we have dotted lines, and then in the y, we have one which is a solid line and the dotted line. Here we also have a dotted line and a solid line. Okay, so let's try now to draw the axis, and then we try to put it there. Okay, this bracket. See if now drawing it. Okay. So we have like that. Okay, so we can actually draw the system. Okay, so I can say I have my y like that. Then let me have my x there. Bad at drawing though. Okay, so I have my x there. Then there I have my y like that. Okay, so I just have to make sure that these 3 axes are at 90 degrees. Okay, so this, I'll say this is my z, this is my y, and this is my my x. Okay, so we start with x. So if this is my 0 there, then I'm moving in the x direction there. Okay, I can have a 1 somewhere like here. Then if this is my 0, I'm moving in the y, I can have my 1 here. Then this is my z, I'm also moving there. I can also have my 1 there. Okay, so then now let me use a different color. Okay, let's say white. Okay, so the first one, they're saying 0, 1, and that is the interval that we said it's actually in the z, in the y. Okay, this interval is in the x here. Okay, I don't know why I'm confusing myself. So if we're dealing with 2 dimensions, right? Let me write it here. If this is a 2 dimension and I want to represent my interval 0, 1, okay, in the x axis like that, it means I'll just draw a dotted line on the 0, right? Then I'll draw a dotted line on the 1 like that. So this interval here between the 0 and the 1 will be represented by that. Okay, so we can see that our axis is there. They are perpendicular to the other axis. So if I'm finding my interval of the x, I'll draw lines that are perpendicular to the y. Yeah, I got kicked out by the network. So I was saying that if we are representing in 2 dimensions, we see that we draw perpendicular lines, okay? We draw parallel lines, parallel lines to the opposite axis, okay? So if I want to represent this coordinate 0, 1, this interval, I mean, in the x, it means I have to draw lines that will be perpendicular to both the y and the z axes. Okay, I don't know if you are. Okay, so the first one, we're saying it's at 0, right? And we said at 0 in this x, the 0 is not included. Okay, so I'll draw a perpendicular, a parallel line to this interval here, a dotted line. Okay, so this line represents the x, but it's parallel to the z. And then I'm going to draw another line that will be parallel to the y, like that. It will go like that, right? Okay, so this is the representation at 0. And then let's go at 1 now. So at 1, okay, at 1, I'm going to draw a line that is perpendicular to both the z and the y-axis. Okay, I hope you are following. So at 1 here, I'm going to go on top like that. So make sure you go 1 unit. So if from here to there it is 1 unit, then it means the 1 unit for here will just be somewhere there, right? It can't reach the same height. So we can say the 1 unit there reaches somewhere here. Okay, so this is what we have here. So this line here is parallel to the z. And then let's draw a line that is parallel to the y. Okay, so parallel to the y, it means this line should go like that. Okay, and then the one will be somewhere there. Okay, so we've represented that interval for the x in the 3 dimension. I don't know if you are getting it. Okay, and then once you represent that, go to the other one, to the y. Okay, so the y, let's use maybe yellow or something like that. Okay, so if I want to represent a coordinate in the an interval in the y, okay, this is what I do when I'm in 2 dimension. Okay, so I want you to refer to 2 dimension and then you take it on the 3D now. Okay, so if I have an interval 0, 1, okay, and this interval is in the y, it means I'll do this. Okay, so the first one, the first 0, it's included, so it will be a solid line just on top of the 0 like that, and then the 1 will be a dotted line like that, right? So you can see that these lines here are perpendicular to the x. Okay, so they are perpendicular to the other axis that this interval is not representing, right? So it means if I want to draw my y here on this, I have to draw 2 lines at 0 that are perpendicular to the x and the y, okay, and 2 lines at 1 that are perpendicular to the what? To the x and y. Okay, so if I draw a line that is perpendicular to the x, okay, I'm going to go in this direction like that. Okay, so this represents the y interval, right? So this line is actually perpendicular. Not perpendicular. Why am I saying perpendicular? It's actually parallel to the x. Okay, and then I also draw a line that is parallel to the y. So if it's parallel to the y, it will go like that. Okay, but this line, take note that here we have this bracket here. So meaning this line here should just be a solid line like that. Even this one should be a solid line like that. Okay, so we've drawn at 0, and then at 1, what are we going to do? Okay, so we are in the y. Okay, so this is the y. So at 1 here, I'm going to draw a line that is parallel to this, to the what? That is parallel to the y, to the z, I mean. Okay, so at 1, I'm going to go up there, drawing a line that is parallel to the z, like that. Okay, and then this line is parallel to the z, and then now I draw a line that is parallel to the what? To the x. Okay, so parallel to the x, if I come here, we see that these guys are going to meet here. Okay, so this was the line that was parallel to the y for the x. And then this is the line that is parallel to the x for the y. Okay, I hope you are seeing that. Okay, so let me represent this one here properly. So it will start at 1, the very place that this is starting. So we can write it here like that. So that will represent 1 unit, right? We are seeing the shape now that is forming. So now let's represent that interval in the Z, okay? So now we know that we just have to draw lines that are parallel to the X and parallel to the Y, because we are representing a Z, right? Okay, so a Z, we draw, I think here I made a mistake. This line here should have been in here, right? If you agree with me, because here we are drawing for the Y. Okay, I don't know why I came. Yeah, this should have been up there, the yellow one. Ooh, now I've ruined it. Okay, anyway, it's okay. Okay, so here we had a line like that, then even a line like that here. Okay, so the yellow one there should have been parallel to the Z, because we are dealing with the Z. So at 0 we should have a line like that, and then it reaches somewhere where we have 1. Okay, and then now let's draw the one that represents the Z. Okay, so Z, we have an open bracket at 0, and then we have a closed bracket at 1. Okay, so meaning we have a dotted line at 0, a solid line at 1. Okay, so I'm using blue now. So let's go at 0 and draw a line that is parallel to the X and parallel to the Y. Okay, so parallel to the X, if I'm using my Z, okay, which line will be parallel to the Z, to the X, I mean? Okay, it will be this line here, and we are saying it's dotted like that. Should reach at somewhere there. And then 0 again, I draw a line that is parallel to the Y, okay? So it means with my blue, which is dotted, I go like that. Okay, so this is for 0, and then for 1 now, okay? And then for 1 now, it will mean that what? It will mean I have to come here where I have 1 in the Z, okay? And then I draw a line that is parallel to the X and the line that is parallel to the Y, okay? So from 1 here, I'm going to draw a line that is parallel to the X. So this line will go like this. Will go like this, and we see that it will meet somewhere there. And then it also goes like this. We see that it will meet somewhere there. Okay, so this is the box that you end up with. Okay, this is the box that you end up with, and then you can actually connect these points here. Okay, you can connect this point here. You also connect that point there, and then you say this point here is connected like that. Okay, and then you have your box here. I hope you've gotten what I was explaining. I don't know, but I hope so. Okay, so for this box, we'll actually have a dotted line here. We see that this is a dotted line, this is a dotted line, that will be a dotted line, and this will be a dotted line. And then since here we had a solid line and a dotted line, it means that dotted line will be overshadowed. So we have a solid line there. And then this side here, we have, what was the, okay, I think even here we have a solid line and then solid, 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 okay? I think it will look something like that, and then you can actually shade it to say this is my region there. I don't know if, I hope I've tried to explain it. How is it? Hello?
How are you knowing that this one is supposed to be perpendicular, parallel,
Okay.
and yes?
Yeah, I'm getting the concept from the 2 dimension, and then I'm getting that concept and applying it to the 3 dimension. Okay, so I was saying if I have an interval, let's say, okay, let me just use 2 and 5, and then this interval is in the X coordinate. Okay, so if I draw it like that, I'll have 2 here, and then I'll have 5. So for me to show this interval here, it means I'll draw a line that is parallel to the y-axis. Even here, I'll draw a line that is parallel to the y-axis. You've seen, and then this will be my area there. Okay. Now, this means that if I have an interval in the x coordinates, it means I'm drawing lines that are parallel to the other coordinates, right? Okay. So there now we had the 3 coordinates. We had 3 intervals, I mean. We had an interval, okay, in the x, we had an interval in the y, and then we had an interval in the z. Okay. So for us to plot this interval in the x, since we are using now a 3-dimension, it means we are just drawing lines that will be parallel to both the y-axis and the z-axis. Okay, and then if you are drawing for the y, it means you're drawing lines that are parallel to the y and the z. And then if you're drawing for the z, it means you're drawing lines that are parallel to the x and the y. Okay, that is the concept that I'm using here. Because here, if I'm drawing an interval of the x and I have just x and y, it means I'm drawing lines that are parallel to the y here. But now to this y, we have added another axis there, which is the z. So it means the lines that I should draw should be both parallel to this and parallel to that. So this is the concept that I was using there.
Yes, understood. Thank you.
Okay, so I think
So,
okay.
sir,
So I think yes.
sir, what should be perpendicular is the three planes are supposed to be perpendicular to each other, while the lines that are showing the coordinates of each plane are supposed to be parallel.
Yes, yes, exactly.
Yes, exactly.
So the coordinate system there, they should be perpendicular to each other. But the lines that you are drawing, they should be parallel to each other. Then you'll be able to draw it. Okay, is that okay?
Yes.
All right, I think we'll end here. When we have Mat2300, we'll do question 3 and 4. All right, have a blessed night.
Thank you.
Same to you, sir.
Mm.